all of these elements, all of these line items within SQL. Okay. We might require one more session. I'm not sure if we'll be able to cover everything today, but we might require one more small session. So today's session, I will try and explain some of the basic things which are there. Okay. So we've seen uh, select statements, insert, update, delete, subqueries as well. Now in each database, okay, be it MySQL, be it SQL Server or Oracle or any other SQL this database, right? Every tool has their own system tables. Okay, like over here you see this is sys, but there are some tables which you will not see over here. Okay, you will not notice some of those things over here. Those are called as system tables. You will not find this. MySQL itself has certain databases. Okay, so if I take this and I run this particular line, select star from MySQL DB. Alright, so here you get what are those tables. So if you can just try this, right? Try this, select star from MySQL user. Select star from MySQL user. You will know who all are the users over here. Just give me a second. So if you go to server in the drop down server and go to users and privileges, right? You will see these users over here. Okay, you will see these other users for this particular MySQL. Okay, basically you have certain system tables which are not visible on the left hand side in the schema. They are like hidden, but many a times you might want to access some of those information. I will give you an example. You can actually there would be a system table for all the columns and fields and everything. Okay, so one second, I'll just tell you. So just try to run this query. You will get a list of tables. Just try to run this query. So are you able to run the query? Getting any output like this? Yeah, so these are all the tables which you see, okay, which are there within this particular system. So there should be one related to the fields also. Yeah, so if you see function, right? So select star, select star, help category will be better. So these are all the keywords within MySQL. If I run this, right, help keyword, if I run this query, select star from MySQL dot help keyword. Okay, if I run this, I get a list of all these keywords. This is an ID and this is a name that I can actually search or find information related to each of these. This is something which is probably a keyword within MySQL. It might be a function, it might be a comment. So I'm sure you will find also select over here. We see insert, right? We see insert is a keyword. Then you'll also find select over here. You see this select. Okay. So this is going to be there in each and every database. Okay. I'm just trying to find out. I'm sure I had got that. Select list of columns, table. Yeah, information schema got. Try this. All right. Now this gives me a list of every column which is there in the database. Okay. This is what is giving me that list. Okay. So if I do superstore.columns, nothing happens. So this is again a system table which you find, okay, based on all the information which is stored you have this information which is kind of stored over here. This is more like something you need to be aware of, that sometimes you want to find out all the columns for a specific, which have a specific variable name, right? So like over here you want to find out all columns which have are there in this particular uh, table. Yeah, so if I search for, yeah, so if I look at this, right, your database, this table schema is us underscore store. Yes, you can search for a particular column also, because you just have to search for the column name. So here I am seeing all the information for US Superstore, all columns which are there for US Superstore. You see this? All the names are there. Now if I want to find out all columns which start with S, so I give and table name, no, and column name rather, column name like, so I get all columns which are starting with S. So this is very easy to find or easy to use when you are trying to, when you have a very large database and you're new towards it, you want to find out what you can, you want to find out specific field names which are there in a particular table. This is what you can use. Does it make sense? If you notice, right, you will not find these names over here on the left hand side. Yeah, you will not find these names on the left hand side because they are hidden. So you need to be aware that there is something like this with MySQL itself is storing in the background. Whenever you create a table, it is stored in a structured format. Make sense? You can even try this. Select star from information schema dot tables. So you will get a list of all tables which are there in MySQL.
So, sir, this will show all the data that we have stored in the SQL from all the data. I mean, like if you have different tables, anything from everything.
This doesn't show you the data. This shows you the schema of all the tables. So how many columns are there? So users has this region and manager. Okay. So if I want to search for this, right, in this user over here, when I run this, okay, I remove the column name. Yeah, so this table name is order. I want to find out all columns for users. Okay, and table name equal to users. So you see region and manager are the two names. So what happens is whenever you create a table, you create a function, a store procedure, it gets stored within MySQL as a table. This entire schema, right, of this table is stored over here. You can notice for each field what is the data type, the column name, what are the privileges which are there. You select, insert, update, references. Making sense? This is like a map of the information which is stored, not the actual data which is there in the table, but the information of the type of table, the number of tables which are there, the number of columns in each table which are there. So you can find this information. Does it make sense? These tables are stored by MySQL. In this case, MySQL, there are many other tools, right? There are many other database tools. MySQL is one. Then you have SQL Server. You have, let's list down. If I look at this, see Oracle, Microsoft, Amazon. These are all different databases. IBM has their own database. You notice these are all databases, and in each of these, right, you will have system tables. Each of these will have their own system tables like this. Whatever we saw, help keyword, mysql.help keyword, and information.schema. You are getting. You can actually check this information. You can find that information. If you have 1,000 tables and you want to search for which columns are relevant for you, and you can do that using these information tables, rather the system tables. Makes sense? No. Now in each table, right, like in Excel, you know this is the key in a way that this is your serial number, right? This is your serial number or an index for you. And I can go on adding a number like this. I can go on adding 17, 18, 19, in this 19, 20. But sometimes you might want to do is you might want to limit that I do not want duplicates on this. I do not want to enter any duplicate data on this. In the sense, now where I can still enter 20. I can enter 20 any number of times. Excel will not give me any error. But in Excel, if you have seen this text to other, you have seen this list, right? Data validation. You can enter only a specific value in a sense. You know? If I just type it 1, comma 2, comma 3, goes that way. Yeah, 1, 2, 3. So I cannot enter anything else. I cannot enter a 4. It will give me an error. That same way over here, I want to limit that you should not enter a duplicate. If this was the roll number, even in your college, no two students have the same roll number. Is that the case? Do two students have the same roll number? Students have the same roll number. Okay, very good. Yeah, so that is what you call is like an index. Okay, that's what you call is or a rather a primary key. In case of an index, you can add a you can allow duplicates. What we do is if I go to any table over here, yeah, and you go to table maintenance, hopefully that's the right thing, and you will see this column and you will see this indexes. There are no indexes over here at this point of time. Okay, if I go to alter table, I click on it, I do alter table, you see that option. primary key. Okay. So here is where I can decide that the region is the primary key. If I decide this region is primary key, not null, it cannot take the value of null. NN means not null. UK means unique index. Okay, binary column, yes or no. Unsigned data. So there are a lot of fields over here, but the important aspect is this: if I decide that this is primary key, whenever I want to start and whenever I enter data over here, now this data, right, this table, let's look at what data this table has. This data has central, east, south, west. So what will happen is I can enter only one value for central, I can enter only one value for east, I can enter only one value for south, one value for west. If I go ahead and create a primary key using region, can you try it? Create a primary key for region. Okay, what did I do? Without a length. Why does it say that? Interesting. 1 minute. So here I applied the primary key for returns. I'm not sure why it was not working for users. But for returns, what we can do is, let's try and insert the data for this. Okay, let's try and insert that. Go back. Put into returns. ID. 65 and return. Yeah, duplicate entry key, it gives me an error. So when I added a primary key, it gave me an error. Okay, now if I remove the primary key, if I remove this primary key, and now if I try to insert this data, it entered the data. Make sense? Because of this primary key, it did not allow you to enter a duplicate value. So the query. So try it. Click right on returns and add this primary key. I'll be back in a second. Do you understand what we did? Any doubts? Okay, I will show it again. Give me 1 second. Okay, let me close this and this and this. In this users column, first right click the users column and alter tables. Okay, if you just click on table maintenance, you will find there are no column index, there are no indexes. Right? There is no index over here. We want to add an index. We want to add a primary key rather. Okay, if I make this alter table and I click on primary key, this is primary key. This PK is primary key, not null. Not null means the primary key cannot be blank. The primary key cannot be blanks. Okay, so that is what it indicates. So I do this, I apply. Okay, I'm taking the wrong table, sorry. I want to do it on returns. In alter table on primary key over here, on returns rather, and I apply it. Okay, so there is a duplicate key over it, there is a duplicate data in this table, which is what, if I apply it now, I need to remove it. So I need to first of all delete the data. So just give me 1 second, 1 second. So now this is not working because there is a duplicate. We added a duplicate over here. Okay, we added a duplicate, so this will not work. So what we need to do is first we need to delete that data which we added. Is it making sense? Why it's not allowing us to uh, enter information? Because we've already entered some information over there. We already entered a duplicate value over there. Where did it go? I'm going to delete that value. Both values will get deleted. Okay. Safe mode update. Toggle the option. Okay. I need to enter that information also. Alrighty. Sorry, 1 second. So I am going to set this first. And I delete this. Now both records got deleted. It's not that only one record got deleted. Okay. And I will insert this value again. Just for my sake. I'm going to set this to 1. And now I'm going to try and do what we did, alter table, enter a primary key, apply, apply. So I have this table. It's got a key over here. Now if I look at this table, table maintenance, so you see this index is added, primary key is added, this returns. And when you enter this, right, in this return, you see which are the fields over there for that particular table. So what we have done is so now if I insert this record, right, now if I go ahead and insert this record, it will not allow because there is a duplicate key for 65. Make sense? Got the idea? Can you try it now? So I put the queries in the chat. You getting the idea? These are basic things. Whenever a table is created, these are very basic things which is done for the very first time. If you define your primary keys, your foreign keys and everything. So when you say foreign key, okay, what it means is you want to have a relationship with another table. Okay, so order ID can be, you can enter data in this table only if there is data in orders. Okay, if there is no order, you cannot have a returns or data in the order ID. That is what is called as a foreign key. Okay, so you can add a foreign key from here at the bottom. You see this columns index at the bottom. You see foreign key, but I'll come to that later. First, try this. First, try this. Did you get it? Are you getting it? right? Did the other two get it? Okay, cool. Like I was saying, when you alter table, right? When you do this alter table over here, okay, at the bottom you see indexes. The thing about indexes, there are foreign keys. So I can add a foreign key over here. Okay, I can add a foreign key, which means that all the data which is there in returns, right? It is based on order ID. If you look at the returns table, it has two columns, order ID and status. Alright. So what we are saying is this order ID should be, so if I say order key, reference table should be order, this should be based on order ID. Yeah. So first of all, it's telling me that order ID in this table should be indexed. So that should also be a key. Okay, at this point of time, it is not a key. So if I want to create a foreign key, the order ID in this orders table should also be a index. Okay, once that is done, I will be able to map it to order ID. It's giving me row ID because row ID is probably indexed. It's the only thing which is, I'm not sure if even row ID will not work because that is also, there is no indexes in that particular table. I don't think we ever created any. So this will work only if both the tables have an index. Okay, makes sense. So basically what you're saying is if I have multiple tables over here, if I have two sheets, okay, order ID, then status, this is returns table, this is orders table, okay, this is order ID, order name. So here if I enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and whatever random name A, B, C, D, this is the name of the order. What we are saying is in this data, let's see if it cannot enter anything. If I enter 20, it will not work. So what it's saying, this is what you call as a foreign key. It will take only values which are present in orders. Other than that, it will not take any value. Make sense? So that's how a foreign key works. Basically, I will not be able to enter any returns unless there is an order, which is logically and practically correct, right? If an Amazon you go and return an order which you never bought, and Amazon allows you, Amazon doesn't allow you that, right? Unless and until you don't see an order in your orders tab, you cannot really return that order. That is the same thing over here. That is a foreign key. So I cannot enter anything over here. And about this, if this is the index, I cannot enter a duplicate return. Make sense? Got the idea? Can you hear me? Okay. I hope you got the idea of a foreign key. The difference between index and primary key is that indexes will allow you, can allow you duplicates. Primary key will not allow you duplicates. You can create an index which can allow you duplicate values, where you can allow duplicate values, but it has to be unique across. In a sense, yeah, it will allow you duplicates, or rather, it not duplicates. It can allow you null values, if I'm not mistaken. It cannot allow you duplicate. It can allow you null values. Otherwise, the purpose of a index will be defeated. You can have multiple columns in a key. Okay. You can make a combination of keys. So in this orders table, I can choose this row ID. I can choose this order ID to create an index. So this is a index with multiple columns. Okay. So here it's creating an index using multiple columns, not just one column. Make sense? I chose two columns over here, order ID and row ID. So that is what I can add.
Sir, can you please explain this again that we are selecting the multiple, the order ID and row ID here? What is the purpose for that? I'm not getting it.
So it's like if you have a table with your name, first name and last name, both of those together make it unique. Yeah, there can be multiple. I'm not sure how many students are there in your class, but there can be multiple Nehas, right? There can be multiple people with the same name, but there is a larger or higher probability that the name and the first name would be unique. Then your name, first name, last name would be unique. First name, last name, and the middle initial can be unique. So from that perspective, you can have multiple. You can choose multiple columns to create a primary key. Primary key need not be only one column, made of one column. So that is why I chose row ID and order ID. Does that give you an idea what I said? So here, let's explain it over here. Okay, I have data. Obviously, roll number is unique. Then you have name, I mean the first name, middle initial, L name. Okay. Let's say I don't have this roll number. So what will happen is you will have to create this combination of first name, middle initial and last name unique. So A, B, C, D. I'll have A, B, C, D. Okay, the last name is P, Q, R, S, X, Y, Z, A. And then I can have another middle initial L, M, N, O, P, Q, R, S. So if I look at this, right? The combination of these three is unique. The combination of just the first name is not unique because there are two records over here. Does it make sense? Like I said, right, there
Yes,
can be
sir.
multiple names with having the same first name. I mean, there'll be people with the first name and last name same also, but with that is the rarity. Ideally, the unique number should be a number. The unique index should be a number. You should avoid using text in a unique number because everything becomes very slow. It's easier to search a number than a text. All right. So here you need to look at this roll number. Obviously one key, but if you do not have that, then you're left with no other option. Then you should create a unique number using these two columns. That is what I did. You don't need to choose only one column as a primary key. You can have a combination of columns over here. So when you did that, right, what I had done was, let me remove this. So when I do this, right, when I select this primary key, I am seeing only one ID, add primary key row ID, in this query. Everything is done through a query only, but there is a good interface which is why using that. When I select the second row, the order ID as well, and I apply this, you see it is making primary key as row ID and order ID. It is not only limited on particular column. Make sense? Alrighty. Got an idea about these indexes and this?
Yes,
So
sir.
again, I can create an index like this over here also. The index name test unique. It is just an index on customer ID. No, already created that at row ID. So again, you can create an index over here also. Okay, this is an index. This is a where you're creating a primary key, a foreign key, which you can create. Let's see. Make sense? There are quite a lot of things. This is more like setting up the data. Okay. Now we're going to look at a very basic join. So last time we had seen a very basic join. Okay, we had seen a very basic join, a very basic format of a join. You don't have anything, you don't know anything. You can join without using anything like left join, right join. But first of all, do you know what is a left join, what is a right join? Are you aware of anything like that? Assuming no. So just give me a second. I will explain the concept at least for today. Okay, just 1 second. So if I have these two tables, I want to find out which employees are your customers. This is your customer table, this is your employee table for a retail store. You want to find out which employees are your customers. What column will you use to check that? Anybody? What column will you use to check that? I see someone typing. Any idea? We'll be looking at employee name and customer name. You can see which employees are your, you can see Jack is your customer. Okay, and Susan is also your customer. Which customers are our employees? Or which employees are our customers? The other way around also is true. So you can see Jack and Susan are your customers. This is called as an inner join, where you're only getting the output of whatever is common across both those tables. So this is like a Venn in a Venn diagram. If you have two tables, what is common between them is an inner join. Make sense? Does it make sense? I have two tables A and B and want to find out which customers are our employees or which employees are our customers. We are finding out which of them are common, what data is common across them. We will use the customer name and the employee name. That is what is called as an inner join. In terms of Venn diagram, whatever is common across both of them, that is called as an inner join. Getting the idea or no? Yeah. So in terms of a left join, what will happen is you're going to take the data of the left hand side. Okay, base data of the left hand side is there. Whatever data is matching from the right hand side, you pick that up, and for the other rows, you add a blank row, blank data elements. Okay, so this data becomes like this. Because you found data for Jack and Susan in the employee table, you see data over there on the right hand side. But for Adam, Benjamin, and Nick, there is no data. So you do not see any output over there. Make sense? So if this is left outer join, what would be right outer join? How should the output look like in terms of right outer join? Any idea what should right outer join look like? Anyone? Any guesses? Okay, so in case of a right outer join, you will have data for all the columns of the right hand side, and whichever data matches for the left, right, you will see that data. So this is how it will look like. You will have data for customer, gender, age for Jack and Susan, but not for John and Mary. So right hand side is the base in terms of a right outer join. In terms of a left outer join, the left hand side is the base. So you'll have all rows of the left hand side, but not all rows on the right hand side. In case of a right outer join, you'll have all rows of the right hand side, but not necessarily all the rows of the left hand side. Make sense? Any questions, folks? Okay, as you know, right? So you have a right outer join which output looks like this. Now, in terms of full outer join, we are going to there will only be two rows of Jack and Susan which have all the columns filled, but for the other, everything else will be blank. Okay, so you are matching everything wherever you get information, right? So you are going to get data of all the rows of right hand side and all the rows of left hand side. And what is going to happen is you have blanks for Adam and Benjamin for the right hand side table, and blanks for the left hand side table for John and Mary. This is what we call as a full outer join. Understood? Make sense, folks? You understood what we're talking about? We talked about inner join where only the common elements of both the tables are there. Left outer join, the base is the left hand side table, and you're getting data of only the common elements of the right hand side. For the remaining, everything is blank. In a right outer join, you're getting the data, the base data is of the right hand side table, and you're only getting data of the common elements from the left hand side. And in full outer join, you're getting the entire combination, which matches, which does not match. All the rows are there. Make sense? Understand the basics of inner join, left outer join, right outer join, full outer join. Any questions, folks? Alrighty. Now there's one more thing which can happen is you can get duplicates in joins. So if I join this table on orders, okay, if I join this table on orders, I will get two records for this 001 order. Okay, you see this, I've joined it on, I've done an inner join on order number. I'll get two records on order number. For 2002, if you see, right, there is one record for 002, one row for 002, so you'll get only one output after the inner join. For 03, I'll get three outputs. So you can have duplicates within this joins. This is the final output that you will get in terms of an inner join. Make sense? That you can get duplicates in joins based on how the data is. Now the final aspect of a join is you can join on multiple columns. Okay, you can join on multiple columns. So you can join on multiple columns over here. If I join just on north, right? If I join or just on order ID, okay. If you join just on order ID, what will happen? That if I look at it, right? 001, 001, 001. There are three 001 orders on the right hand side and 2001 orders on the left hand side. If I join just on order number, 001 comes like this. I get these three. For 002, I get just one order. Again for 001, I get three orders. So ultimately what will happen is, if I look at the data, right, and if I am trying to find out the total sales based on just the order ID, things are not going to look correct. Because north and south store, you are matching the order numbers of north and south store, which is not correct. Okay. Same in case of south, there is only one order of south. Okay, if I look at the data, right, for the south store there is only one order. But what is happening is, when you're joining just on the order number, the output you're getting is 3 rows, which is not correct. Which is why you need to match on 2 columns in this case, because this is an error. You need to match on 2 columns. It is order number and the store name. Store is north and south. When I do this, when I join on 2 columns, I get the correct output. Make sense? I get the correct output like this. Got the idea? Make sense? Yes or no? You understood left join, right join, inner join, full outer join. You're going to try one small join, a left join. You're going to try this. This is the same thing. The way it's written is it matches the orders which are there in both the tables. Orders which are there in both the tables. Okay. In this case, the way it's written is, you have to write select, yeah, the column names, whatever columns you want from table name is normal, which is normal over here. The only thing we are putting a alphabet A. Okay. And then we write your left join, right join, inner join, full outer join, what else, whatever you want to do, right? We write left join, the table name, yeah, table A. So I'll put this table A, table B and B. And on what do you want to join? I want to join on name A equal to column name
Excuse me,
B.
sir.
Yes.
Sir, just we got a message from our college that we are having a meeting with our placement officer, so within 10 minutes. So, sir, uh,
Yeah, we can continue. I just wanted to explain this. Just give me a couple of minutes.
yes,
I'm going to complete in any case now. Just give me a couple of minutes. Is that fine?
yes, sir.
Yeah. So I just if you run this, right, this is the structure of it. The only thing, this column A, this B and A is a synonym for this table. If you don't put this A and B, you need to write orders dot order ID, orders dot order priority, orders dot discount, orders dot unit price, and for B, returns dot status. Okay, so if I run this, I'm going to get the same output over here like this. The left outer join, we can look at it again next time. We'll look at it again next time. Okay, that is all I wanted to explain for now. So we'll continue again, hopefully this Saturday or Sunday. All right. Okay. Thank you so much. Bye bye.